Jim Burnett of NASA's Lewis Research Center in Cleveland, Ohio. We'll see two films during this episode of the history of space travel. Now let's see the first, called Before Saturn, released in 1962.
Saturn is the first of a great line, first of a family of rockets which will open deep space to science and carry humans to other planets. Space is open to us now. This, the second half of the 20th century, is the moment in time when our maturing space technology can begin to support the imagination of the past. Yet what is past before Saturn is important. It is easy to say, looking at the Saturn vehicle, this is a product of our space age. These are the people of our space age. Only these same men know full well that the journey to space began not a few years back, but a long, long time ago. How long? How far back? In ancient Greece, there was the poet Lucian. He tells of a ship lifted into the air by a great storm and carried to the shining island of the moon. But, said Lucian, these were things which were not and never could have been. And for 1,000 years thereafter, the men of science agreed. Everyone knew the Earth was the only world and center of the universe, and the stars, well, dots of light, illumination. Until in the Middle Ages, the great astronomers and mathematicians, Copernicus, Galileo, and Kepler, they said, there are other worlds, and proved it. Kepler went further. He conjured up the first human visitor to the moon, a man pulled by demons across the shadow which falls from Earth to the moon during an eclipse. Later, in 1638, two English bishops published serious works on travel to the moon. Fiction, to be sure, but regarded as a blend of witchcraft and satanic knowledge by their contemporaries. Still, it remained for the 19th century and its remarkable prophet, Jules Verne, to bring together the facts and fantasy of space travel. Space travel, announced Monsieur Verne in 1865, may be accomplished by being shot from a huge cannon, a cannon with a barrel 900 feet long. In his story, veterans of the American Civil War band together for the adventure. They sink the cannon barrel below the Florida terrain and then are off to the moon within the hollow cannon projectile. Of course, in reality, the projectile would have fallen far short of the moon, but the velocity computations were surprisingly accurate. And astonishingly, Monsieur Verne hit upon a very familiar launch area. Today, the sites of our space launch areas are everyday images worldwide. And we all know that the rocket, free to operate in any atmospheric environment, is the ideal transport to space. But in the not-too-distant past, this was not readily apparent. It took men of genius. In Russia, the effects of scarlet fever rendered Konstantin Tsiolkovsky totally deaf. Plunged early into a silent world of fantasy, his enormous talent quietly produced solid technical studies in a brand new field, astronautics. There were many visionaries, among them the remarkable Hermann Ganswind. His theoretical knowledge of propulsion was less than sound, but he did set down plans for a workable space vehicle. And moreover, he paved the way for the small group of European rocket pioneers who now appeared. Of these, one name stands out. Hermann Oberth came from provincial Romania to Germany after World War I. By 1923, at the age of 29, he perfected a complete series of mathematical theories on space travel. His book, when at last he found a publisher, caused a small sensation. In Europe, A stimulated public eagerly discussed Obert's descriptions of rocket space travel. In America, the rocket remained the perennial pyrotechnic every 4th of July. Yet one man, working a quiet lifetime in self-imposed isolation, created a whole space rocket technology. In 1919, the Smithsonian Institution published a report. The author, an obscure New England scientist, Dr. Robert H. Goddard. Today, the Smithsonian houses many of the rocket artifacts of Dr. Goddard's career. They present a vivid profile of a step-by-step mastery of the theory of rocket propulsion and its practical application. The first liquid propellant rocket flown successfully by Goddard. The first development of liquid cooling for a rocket nozzle. The development of fuel pumps. The use of vanes in the jet stream, coupled with gyroscopes for direction control. All these fundamental technical breakthroughs were Dr. Goddard's, and his work is embodied in every rocket which has flown since his work was done. And in his time, like the other pioneers, Dr. Goddard had his problems with the public, and particularly the public press. His professorial report somehow electrified the nation's editors, at least for a day. But within 24 hours, common sense prevailed, and Dr. Goddard received the editorial reprimand reserved for crackpots. Despite this, the idea of rocket travel was infectious. The widespread symptoms of the era became apparent even to the editor of the Times. People everywhere had rocket fever. And out came the fringe area rocket specialists to join the game. Any number could play. In Central Park, Prince Mikalikais demonstrates his invention. And there were rockets for boat propulsion. And in Europe, rocket race cars, rocket rail cars, rockets for ice boats, rockets for gliders. Through it all, aiming toward the true ultimate use of rocket power, space flight, the pioneers quietly sharpened their skills and tried to explain their accomplishments. Today, accomplishments are explained to a vast space news-hungry public. We accept space. We understand something of the rocket's role and that of the rocket's passenger, man. But again, looking back in the dim recesses of history, who was the first man to try for a space flight? Ah, that's right. Who? Wan Hu. According to ancient accounts, this Ming Dynasty astronaut fitted his bamboo spacecraft with all the black powder fire rockets it would hold. And when the rockets were ignited by a platoon of pigtail technicians, Wan Hu was converted gloriously from the living to legend. In the 1920s, one man might have eventually created a real moon vehicle. He was persuaded to build one, quickly, for the movies. Professor Obert's space rocket for the film The Girl in the Moon, while technically accurate, was a hardware fantasy. It could never have gotten off the ground. With typical ingenuity, the pioneers appropriated the movie moon rocket and used it to raise research funds. And on both sides of the Atlantic, the store of rocket knowledge grew. In America, the young men of the American Rocket Society built and flew liquid propellant rockets. In Germany, the Society for Space Travel attracted the best young development minds in Europe. Among them, a promising student engineer who neglected his classes to work at the grandly named Berlin Rocket Airport. But But with the approach of a second world conflict, the rocket once again went to war. Chosen to head the vast research and development project was the youthful Wernher von Braun. With an early start, support by the German Army, and the best rocket technicians, the first long-range ballistic rocket weapon came into being. And by 1942 at Peenemünde, the V-2 was ready for flight. The V-2 was still far from perfect, but the money and brains expended on its development had elevated rocketry from gadgetry to applied science. At the end of the line, the collapse of the 1,000-year Reich, the acquired German rocket capability could still turn out 900 large rockets a month. Some of its skilled practitioners were lost. But at the request of the United States, many V-2 engineers chose to work in this country. At White Sands Proving Grounds, they joined with American engineers to resume rocket development. But once again, in the troubled air of the mid-century, rocket development meant development of rocket weapons. All the rocket scientists held fast, nevertheless, to their first faith, the rocket for the exploration of space. Along with the evolution of the missile family, the plans were itemized for the eventual and inevitable space project. Thus, when the Russian satellite Sputnik 1 opened the space age, Explorer 1 was placed in orbit soon after. The conquest of space had begun. Saturn followed, the necessary space servant of the nation. Designed to further the most ambitious space programs, Saturn was planned, built, tested at the George C. Marshall Space Flight Center, and ready for launch in little more than 3 years. But the huge rocket, the men who made it, and the men who fly Saturn are beholden, indebted to those who dreamed of space before them. The roster is long. At the top of the list, the visionaries of old, dreamers of a long-ago age of wisdom. Astronomers of the Middle Ages. The enthusiasts of the 19th century. The dedicated theoreticians of the 20th century. The development team which brought rocket techniques acquired in another land, another time, and for other objectives, to bear presently on the universal objectives of space exploration. For some of the pioneers, it is still possible to visit and to marvel at the giant their early efforts helped make possible. Some have become part of the team now working to create the Saturn family. But with Saturn and all men who work towards space, history begins anew each day. The fulfillment of the dreams of centuries is just ahead. The great events of history are now visible. Saturn, the space vehicle, now joins this history. Same history, new chapter.
And that's before Saturn. Now, let's see America in Space, first released in 1963.
October the 1st, 1963. Here in Washington, the day begins quietly. For some, it starts early in a federal agency that today marks its first 5 full years of accomplishment. This is NASA, the National Aeronautics and Space Administration. As the day begins at NASA headquarters in Washington, and dawn comes to the Capitol, the rising sun outlines the gantries at Cape Canaveral. NASA's Launch Operations Center begins a new day. At other NASA stations, far to the west, it is still night. Signals from satellites in space are being monitored for later study. NASA's 5th anniversary comes quietly. Yet these 5 years have been memorable, exciting. Most Americans can remember the rockets climbing into the sky with their cargoes of instruments, or of men. And a nation's pride in its new achievements in space, and the tribute offered to that new breed of man, the astronaut. They remember anxious moments, too, as search planes hunted a capsule returned from space. What America achieved in those first 5 years of the civilian space program was done openly. A nation dedicated to freedom of inquiry could not do otherwise.
Bear with me, I will get you a number and deliver that tomorrow.
These were the years Americans learned new words. Liftoff, SYNCOM, Tyros, fly-by-wire. If our successes were spectacular, so were the failures. Failure itself was studied, closely, patiently. Progress into space must come step by step. To NASA facilities like Goddard Space Flight Center came research scientists, Americans and visitors from other nations. They saw programs that investigate fundamental physical phenomena, an indication of NASA's increasing role in the advancement of basic knowledge. From these centers across the nation, NASA's space program is guided and directed. In 5 years, the world has been dotted with a network of tracking stations that monitor space probes, unmanned satellites, and our astronauts in orbit. The status and position of every space vehicle and a mass of other scientific data are transmitted from the tracking stations to control centers. All of these facilities are staffed by engineers, scientists, and technicians already veterans of the space age. From these ingredients of knowledge and skill, of facilities and equipment, of a guiding organization, America's achievements in space have been created. They began more than 5 years ago, when America's first satellite, Explorer 1, rose from its launching pad. It carried into orbit the means for performing an historic scientific experiment, one that first revealed the Earth's belt of radiation. It has been followed by well over 100 spacecraft launched by the United States. Satellites and space probes on scientific missions are the vehicles for experiments by the Earth-bound investigator. Here is the space probe Mariner 2, shortly before its 1962 launching on an historic flight to Venus. For 109 days, Mariner transmitted back to Earth continuous data on conditions in space. Then, at a distance of 36 million miles, it sent back important data on the planet Venus, a record-breaking achievement. One of the scientific satellites, the orbiting Solar Observatory, has provided precise information about the sun and the effect of its radiations on the upper atmosphere. The satellites and the space probes have given man new tools to study the mysteries of the universe, where before he could only wonder and speculate. Other satellites, some of them closer to Earth, are solving practical problems in the field of communications. The first to go up was Echo, a giant balloon. It provided a surface in space from which radio signals were reflected. Telstar, privately financed and NASA launched, and Relay, NASA's own satellite, heralded a new era in global communication. Their first transmissions dramatized the future, a permanent system of communication satellites. A satellite that maintains an almost fixed position over the Earth represents another approach. Here, messages are received from SYNCOM, hanging 22,000 miles overhead. The weather satellite Tyros, mounting 2 cameras and a television tape system, returns photographs to Earth on command. Tyros photographs of cloud cover are valuable aids in discovering the growth of storms and in plotting basic weather patterns. But no satellite, however complex, has the power of observation and understanding possessed by man himself. There is no substitute for manned flight into space. In the famous X-15, NASA continued a development in rocket-powered aircraft extending back over 15 years. Over 100 times, the X-15 has climbed above our atmosphere. It was the first craft to demonstrate that man can fly into space, control his flight during re-entry, and select his landing point within 1,000 feet. Project Mercury, the manned orbital spaceflight program, selected 7 pilots after intensive screening of many candidates. Skin diving was one part of an elaborate program to train them for flight into space and a safe return. They studied the navigation, the engineering, the physical problems of space flight. They learned the sheer ability of the human body to withstand high temperatures. And experienced other punishing stresses of a journey out of this world. Zero gravity, that peculiar property of spaceflight, was sampled in an aircraft flying a controlled arc. Finally, the long program of training, development, and testing was complete. Opening the major phase of Project Mercury, there were suborbital flights by astronauts Shepard and Grissom. Then in February 1962, John Glenn rode this Atlas rocket into space for a 3-orbit flight around the Earth. Project Mercury moved into high gear. Within 3 months, another successful flight was completed by astronaut Scott Carpenter. Then a 6-orbit flight by astronaut Walter Schirra. In May 1963, when Gordon Cooper returned to the Earth after a flight of 22 orbits, American spaceflight reached a state of high precision. Project Mercury was completed, but it was only a first step toward the goal that now lay ahead. A voyage to the moon and return by 1970. It would be an historic achievement with immense practical consequences. But the technical problems dwarf those solved in Project Mercury, demanding absolute precision in orbiting and new techniques for rendezvous, docking, and landing. comes Project Gemini. Unlike Mercury, 2 men will fly Gemini in orbit for up to 2 weeks, practicing space rendezvous and docking. Gemini capsules are now being built and tested. Apollo, the 3-man craft that will actually go to the moon, is also undergoing a long period of test. This is Saturn, first of the family of giant boosters that will lift man to the moon and beyond. Product of more than 5 years of intensive research and development, Saturn undergoes a major flight test. On this day, we moved at least 1 step closer to the moon. Visiting Cape Canaveral are the new astronauts, the men who will join the original 7 and ride the Gemini and Apollo spacecraft. They are the new pioneers of space, but their path has already been charted by those who have gone before. For these first 5 years have been a sustained effort, an effort that has broken through the first barriers to man's exploration of space. Because of this first giant step, the cosmos opens itself to man's investigation. What will he discover on these journeys? Already he has seen the Earth as never before in his history and viewed parts of the universe with new clarity. Perhaps now he'll discover clues to the origin of life itself, and through them a glimpse of its purpose and his own. These 5 years have seen the first bold steps forward. Today, experienced, tested, capable, we look with confidence toward the future and our path to the stars.
And so ends our second program. Next time, we'll see a film about America's first 7 astronauts. Until then, this is Jim Burnett saying goodbye from NASA's Lewis Research Center in Cleveland, Ohio.